Different vocational series in YouTube tutorials. Today we'll be doing a help to some of my students doing a simple linear regression and a typical exam question. So what we have here in front of us is we have 11 students recorded. Their heights are there and their corresponding weights are given. There's a statistical summary here. There's 11 data points, 11 students. The sum of the heights, so 1.36 plus 1.47, etc., etc., plus 1.74 plus 1.81 is 17.72. 1.36 squared plus 1.47 squared, etc., etc., plus 1.74 squared plus 1.81 squared gives 28.705. The sum of the weights is 737. 52 plus 50, etc., etc., plus 73 plus 67 is 737. 52 squared plus 50 squared, etc., etc., plus 73 squared plus 67 gives 5571. Finally, 1.36 by 52, 1.47 by 50, etc., 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 plus 1.81 by 67 is 1196.1. First bit of the thing was graph the data. Did this in Excel. You'll be asked to do it by hand. Just a note here, I've given a title. I've labelled the x-axis, I've labelled the y-axis, but if one was being critical, I haven't given the units. I should, by rights, have said that the weight is in kilograms and the height is in meters. The one was being critical. Next bit of the question. Justify your choice of independent and dependent variables. So what goes on the x-axis and what goes on the y-axis? The thing that goes on the x-axis is the thing that causes the effect, is the determiner, whatever way you want to look at it. So so it would seem reasonable that your weight is determined by your height to some extent. So the thing that causes the effect, it goes on the x, so that is height, and the thing that is affected goes on the y, which is weight. Part C of the question, find the line of best fit, which Excel is given there, by the way, but we have to do this by hand. The formula is given here. So slow down a bit. Sigma xy 1196.1, sigma x 17.22, sigma y 737. The number of obs is 10. That gives me 8.86. The bottom bit here, sigma x squared, that's square each x and add them up, is 28.705. Sigma x, all the x's added up, squared is 17.22 squared over 11. That gives me 0.1599. That gives me 54.482. So the slope of best fit is 54.482. And the best slope is given by the formula here, there, and also there. Y bar is 67. B1 hat, the slope of best fit is 54.482. And x bar is 1.61. Do the numbers, you get minus 22.326. Not asked for, but what does that mean? So for every meter in height increase, your weight will go up by 55.482 kilograms, or more realistically, for every centimeter you go up, your weight will go up by 0.55 of a kilogram. Okay. And B0, a bit silly in this case, but if one's height was 0, one's weight would be 22.737 kilogram. I know that's silly, but that's just the way it is. Next bit is, just get the mouse running, is r squared. Explain r squared. And I think the last line says it better, the last paragraph. The higher the r squared, the better the model. So if r squared was 1, the points would lie in the line completely. If r squared is 0, there's no correlation, there's no explanation at all. So what's r squared here, I think, is around 41%. So we'd say, on average, 41% of one's weight can be explained by the height of the person. So the other 59% is due to other factors. Next bit of the question. What is the estimate the height of someone who is 1.6 meters? My line of best fit is y equals 55.482x. Where did I get that from? Remember the best slope, 55.482x, plus c, plus b naught. And b naught is minus 22.3767. You're asked to estimate the height when it's 1.6 meters. So for x, I put in 1.6. So 55.482 by 1.6 minus 22.3767 is 66.395. So in other words, you would expect, according to the model, a person that is 1.6 meters high to have a weight of 66.395 kilograms. Hope that helps. Thanks very much for listening.